This year, one of the things that you're going to be required to do is to fill in math notes. So I took each one of the math notes in your textbook and made a closed notes page for it, where you're going to fill in the definition and some examples of the different topics, as well as have to answer questions through an Edpuzzle. The first one we're going to talk about is functions. So make sure you have your paper out so you can fill in as we go. So the definition of a function is a relationship between inputs and outputs is a function if there's exactly one output for each input. So there cannot be the same output for two different inputs. If there is, it's not a function. So functions are often written as y equals some expression involving x, where x is the input and y is the output. The following is an example of a function. So y equals x minus 2 in parentheses to the second power is considered a function. Because if you notice in the table, there's several inputs with several outputs, but no two inputs have different outputs. Okay. Another way to tell is you could do the vertical line test. So if you took a vertical line and slid it across the graph of your function, it wouldn't touch more than one point at the same time. So again, with the same equation, it depends. So in the example above, the value of y depends on x. So we call y the dependent variable because it depends on it. And x is called the independent variable. So x is independent. We can pick any x that we want. And then y we can get by using whatever x is. Another way to write a function is with function notation. So we can write f of x instead of y equals. The function name f has an output f of x. The input is x. So when you're looking at solving a function or evaluating a function, if it asks you to evaluate a function for the given x equals 5, you're going to plug that into the function. If it says if f of x is equal to 5, you're going to set where y would have been equal to it and solve the function. So over here is an example of what a function machine could look like. So if we wanted to plug in 5 for this function right here from our example, we replace x with 5 and we get 9. So we can rewrite it as f of 5 equals 9. So I can know just by this notation that 5 was plugged in for x and that answer to that was 9. Okay. So in the example at the right, f of 5 equals 9. The input is 5 and the output is 9. You read this as f of 5 equals 9. The set of all inputs which is an output is called the domain. The set of all possible outputs is called the range. In the example above, notice that you can input any x value into the equation and get an output. The domain of this function is all real numbers because any number can be an input. But the range is a little bit different. It's y is greater than or equal to 0 because of this. To the second power, y or f of x can never equal a negative number. Okay, so right here, this is an example of something that is not a function. So x squared plus y squared is equal to 1 is not a function because there are two y values outputs for some of the x values as shown below. So we can plug in 0 and get negative 1. We could also plug in 0 and get positive 1. So because there's the same x's have different y's, it becomes not a function. Also, if you remember, I talked about the vertical line test. If we run a vertical line across this function, it's going to hit in more than one place at a time.